So let's study the high order and low order interleaving again from this PowerPoint. Suppose we have 2 kilobytes memory chip. So here the notation 2K means we have a 2 kilobytes. Each byte has a 8-bit is the notation. So length and width the notation. We have a 16 of those one. So something like that. This is 2 kilobytes memory and we have 16 of them. So all together we can address a 32 kilobytes. So 16 times 2, 32 kilobytes. For 32 kilobytes, we need 15 address lines because 2 to the 15 is 32 kilo. So we need 15 bits. But in 2 kilo means 2 times 2 to the 10 is 2 to the 11 means each memory chip needs 11 address bits. So this has 11 bits, 11-bit address lines and so on. But the remaining 4 bits, we need to select one of 16 chips. 4 bits means 2 to the 4 is 16. So using 4 bits, we are going to choose one of 16 chips. And within the chips, we have 11 address lines like together. So as we learned in the previous videos, so let's try to do some high order interleaving and low order interleaving based on that. So high order interleaving is we use most significant bits to select the chips. So most significant 4 bits are used to select one of 16 chips, and then each chip receives 11 address lines in parallel. Then address space will be continuous from first chip. Suppose this is the first chip, then we have address 0, 1, 2, 3, and then all the way up, and then it continues and continues. That's a high order interleaving. But if you use a low order interleaving, then least significant 4 bits are used to select one of the 16 chips. Of course, we need a decoder that is a 4 by 16 decoder, 4 bits, and then we have 16 outputs. Then select one of the chip, and then most significant 11 bits are connected in parallel to each chip. Then in this low order interleaving, the address space would be like that. So we have a 0, 1, 2, and all the way to 15, and then 16, 17, and the like. So addresses are distributed in this way if we do low order interleaving. So let's take a look at in other way. Another thing is that suppose we have 4 bytes per chip, and then suppose we have 8 chips. Then how we could configure this one in high order memory, since we have 8 chips, which is 2 to the 3, so we need 3 bits to select one of the 8 chips. So high order interleaving, so most significant 3 bits are used to select one of the 8 modules, 8 chips. And then each chip has 2 bytes, which is 2 to the 2, need 2 address lines there. So if we assign this way, of course, to select one of 8 out of 3 bits, we need a 3 by 8 decoder, 3 bits, and then we have 8 outputs. So using this one, we select one of the modules and the like. And then address space will be module 0, chip 0, we have a 0, 1, 2, 3, since it's a 4 bytes, and then next one gets a next address space, 4, 5, 6, 7, and so on. That is a high order interleaving. And now you can see that as a table form as well. So high order interleaving means the most significant 3 bits are used to select module, and then least significant 2 bits are to select a byte within the chip. Then you have a module number, and so on. Then we have a decimal address space like that. That is depicted here. But if we use a low order interleaving, which means that the least significant 3 bits are used to select one of the 8 modules, and then most significant 2 bits are connected in parallel to all 8 modules in parallel, then address space becomes 0, 1, 2, and all the way to 7, and then go back to module 0, 8, and the like. So addresses are assigned this way. That is a low order interleaving. So in memory organization, so that is like that low order or high order. So another example is that suppose we have 128 word could be byte or more than byte and memory. That is a 8-way low order interleaved. So which means we use 8 memory banks, which is 2 to the 3. Then if you use a low order 3 bits to identify the bank, that's a low order interleaving. So 128 means 2 to the 7 is 128. So we have a 7 bits address, but since we have 8 memory bank, so 8 chips, 8-way means 8 memory chips. So in low order interleaving, since 8 means 2 to the 3, we need the 3 address lines to select a module, and then most significant 4 bits are used to locate one of the word within the chip. So that is a memory organization for 120 word memory, that is 8-way low order interleaved.